You know, the Pythagorean theorem is definitely one of my all-time favorite theorems from geometry. I love it. I hope you love it too. And in fact, it's really, really useful. You can actually use the Pythagorean theorem to answer all sorts of really fun questions. Let's take a look at one ourselves and see if we can figure it out. Okay, a child has an empty box that measures 4 inches by 6 inches by 3 inches. Here's the challenge. What is the length of the longest pencil that will fit in the box, given that the length of the pencil must be a whole number of inches? So 0, 1 inch, 2 inch, 3 inch, 4 inch, 5 inch, and so forth. Okay, now this is a real fun question because first we have to actually build this empty box, which is really a rectangular prism, and we have to put in its dimensions of 4 inches by 6 inches by 3 inches. So I've done that, and here it is. So check it out, and you can see that we have 6 inches, 4 inches, and 3 inches. Now, what's the longest pencil that can be brought in? Well, if you think about it, the longest pencil would represent the longest distance, or the furthest distance or length that we could fit into this box. And actually, if you think about it, it would actually be going from one corner of the box to the exact opposite corner of the box. That is the longest distance you can have within a box like this. If you're going from point to point and looking for a straight line, that's the longest straight line that will fit. Anything else will be actually shorter. So we have to figure out that distance given these particular lengths. All right, well, how do we proceed? Well, it's not clear what to do here. I think this is kind of a tricky question, actually. But here's the really cool thing that I rather like, and that is that I can, if I want to, notice that I've got a little right triangle in here. Check it out. That's actually the hypotenuse of a triangle that has this length here, which I'm calling S. That's the diagonal just along the floor rectangular face. And this side here. So check it out. This angle right here is really a right angle. Do you see that? And so it's like a little right triangle that's kind of there hidden, and we're looking at it kind of with perspective. So even though it doesn't look like a right angle, if you think about it, it's a right angle because that edge fits together with the floor at a right angle. So do we know this length? Sure, that's just the height. That's 3. So I know that's 3, so that's really, really easy. And this is the length I want to find. That's the longest distance that we can fit in this box, and I'm calling this S. So I could actually now use, happily, the Pythagorean theorem. And you know the Pythagorean theorem. It says that if you have a right triangle and the sides are A, B, the side lengths are A, B, and C is the hypotenuse, the longest side, then A squared plus B squared equals C squared. Okay, so in this case, what I could write here would be the following. So this is really kind of cool, because what I can say is that S squared, whatever that is, plus 3 squared is going to equal this R squared. So if I could figure out the S squared, then, in fact, I could figure out the R squared. Well, now let's look at the S length and check out that S actually is the hypotenuse of another right triangle. Now, can you see the right triangle for which S is a hypotenuse? It actually lives on the floor. Check it out. It's right here. That doesn't maybe look like a right triangle, but it is. Do you see where the right angle is? The right angle is right here. There's the right angle. It's a perspective drawing because this edge of the rectangle side and this edge of the bottom rectangle side meet at a 90-degree angle. And so, in fact, this is a little right triangle. And we know this length is 6, and this is just the width of the box, which is 4. And so, in fact, we could actually use another application of the Pythagorean theorem to actually figure out the S squared. So let's try to do that for fun. Okay, so here we go. Remember that this is 4 and this is 6. And so what I see here is that the width squared plus the length squared equals the hypotenuse, which is s squared. And so now let's plug in some numbers. The width we know is 4, so that length, remember, is 4. And so I see 4 squared plus the length is just 6. That's 6 squared, and that equals s squared. S squared is what I'm trying to figure out. Well, 4 squared is 16. 6 squared is 36, and that equals s squared. And 16 plus 36 is 52. So 52 equals s squared. So let's just remember that 52 equals s squared. And let me see if I can actually even grab that right now. So here we're going to grab it. Boom, I got it. And so now, let's see if we can actually now go back to where we were. Remember, where we were was to this question where I had to figure out what s squared is. And now we actually see what s squared is. We see that s squared equals 52. So using that, I can now plug in. Let me just move this to the side. All this to the side over, because we've enjoyed that. And I can now plug this in and see that the s squared is 52. So I have 52. Whoops, but I want to use black. 52 plus, and 3 squared is 9, equals r squared. That's what we want. Well, 52 plus 9 is 61, and that equals r squared. And so if r squared equals 61, then r must equal the square root of 61, because r is a length, and so it's positive. When you take square roots, we have to worry about negative too, but not if it's a length, so we just take the square root. And if you use a calculator, you can actually see that this is approximately 7.8. Now remember, the pencils that we're looking at have to be whole number length, right? The inches have to be whole numbers. So what's the largest whole number that's less than or equal to 7.8? The answer would be 7. So 7 inches is the largest length in whole number units of a pencil that will fit in this box. And the way it would fit, by the way, just to make sure you see it, would be kind of like this. You see, it would kind of live like this. I'll draw the pencil in. You see, it's going to go right in here. Look at me go. Actually, this is kind of a good pencil, isn't it? There's the eraser, you see, and then there's the top part. It's kind of here. There's the lead, you see, and it's a little crinkly up here. And that's how the pencil would fit in, from one edge to the opposite edge, and then you can really see it. And 7 inches is the biggest we can have it. So there you have it. Thinking about the Pythagorean theorem allows us to solve all sorts of problems, even ones that involve first using the Pythagorean theorem once and then applying the Pythagorean theorem again. And in this case, by 2 applications of the Pythagorean theorem, we're able to see what kind of pencil will fit into a particular box. I wonder if this pencil would fit in the box. This seems really big. But the Pythagorean theorem is a really big theorem, so you never know. Have fun playing with the Pythagorean theorem. I will see you soon.